What's up, everybody? This is Mr. Richardson coming at you live through the power of the internet. And what we're going to be talking about today is how we can create confidence intervals using a margin of error. If you're just getting here now, make sure you've checked out my previous video on how we can create sample surveys that don't contain bias. All of the information in that video is going to be vital for our understanding of confidence intervals and margin of error. Let's jump right into it by reviewing what we did last time. One of the first definitions we looked at last time was population. Population is the group of individuals that we wish to know something about. Maybe we want to know something about high school seniors. Maybe we want to know something about all of the teachers in a certain region, whether that be a state or a country. That is the population. The sample is the part of the population that we can actually study. If I want to know something about high school seniors throughout the entire city, it may be difficult to get in contact with all of them. So I would study a smaller sample or a smaller piece of those high school seniors that will give us information about our data. So let's look at a specific example to bring these definitions to light. Let's imagine for a minute that I'm a huge fan of Justin Bieber, and I want to know what percentage of New Yorkers also love Justin Bieber. Well, what I can do is I can go outside of a New York City subway station and ask every 10th person that comes out of the subway station if they love the Biebs. Well, imagine I did this and 25 people told me that they love the Biebs and 75 people said that they don't love the Biebs. In this example, what is the population? Well, here the population, remember, is the group I want to know something about. I want to know something about the total number of people living in New York City, so that would be the population. In this example, what would be the sample? Remember that the sample is the part of the population that we study in order to gain information. Our population is the number of people living in New York City, so that part of the population we study is those 100 people I ask if they love the Biebs outside of the subway station. What is the percentage of people surveyed that actually love the Biebs? Well, in this case, I surveyed 100 people, and of those 100 people, 25 of them said that they love the Biebs. Taking 25 and dividing it by 100 says that I get 25%. Is this number accurate? Do 25% of New York City residents love the Biebs? Explain why or why not. The answer to this question is no. That number cannot be accurate. I don't know how many people in New York City love the Biebs. I only know that of the 100 people I asked in my sample, that 25% of those love the Biebs. So this number cannot be accurate for the population of New York City. I certainly haven't surveyed enough people. So we want to ask ourselves, how accurate is this number? If I was to conduct this survey again and ask another 100 people, would I get the same number? Would we get something similar? And that's what confidence intervals and margin of error is all about. Let's look at some key definitions. The margin of error is the maximum expected difference between the true population parameter and the sample estimate of that parameter. In this case, the sample estimate was 25%. We knew that 25% of those 100 people I asked loved the Biebs. But what would it be for the actual population or for all of the people in New York City? Well, what the margin of error would tell us is how far off I could be. Let's say the margin of error is 10%. That means that maybe 35% of New York City residents love the Biebs, or if I subtract, that could mean that 15% love the Biebs. A 95% confidence interval is an interval that gives us a set of likely values that we are very certain that a specific value falls between. So what we want to do for the confidence interval is we want to find what is the maximum value for the population and what is the minimum value. In regards to the Justin Bieber example, we know that we got 25%, but it's likely that if I did this again, there'd be a higher value and a lower value. Let's look at an example to give this some meaning. What we want to do is find to the nearest percent how far off our results were when we found out that 25% of the people in our sample loved the Biebs. Meaning, we want to know if we were able to test everybody, which we're not able to do, how many New York City residents would love the Biebs. Well, the first thing we want to do is bring up our margin of error formula. In this formula, p hat is the proportion of people in our sample that love the Biebs, and n is the sample size. Well, p hat is going to be 25%, or 0.25, and n was the 100 people we asked. So we just plug that into the formula. When I calculate this, I like to do it in multiple steps. The first step I do is I do this product in the numerator. Then I'll do the division of the numerator divided by the denominator. Finally, I do the rest in one piece, making sure I have parentheses around the radicand. When I do that, I get this decimal here, which still is not a percentage, so I multiply it by 100. Here they said to round to the nearest percent. 0.6 means to round this up, and I get 9%. Well, what does this mean? This means that when I found out that 25% of New York City residents love the Biebs, I was probably off by as much as 9%. This means that if I conducted this survey again, the number that I would get could be higher by 9% or lower by 9%. I can use the margin of error to find an interval that I would be fairly certain of the number of New York City residents that love the Biebs. To create a 95% confidence interval, use this formula here. P hat is the percentage of New York City residents that said they love the Biebs in our sample, and the margin of error is how much this is likely off by. I know the margin of error is 9%, so I plug those in. Well, 25% minus 9% will give me the lowest possible value that I expect. 25% minus 9% is 16%, and adding the 9% gives me the upper value. This here is an interval that represents what is likely to happen if I conduct this sample survey again. Meaning, if I survey 100 people another time, I'm likely to receive a number that is between 16% and 34% of New Yorkers that love the Biebs. So is it reasonable to believe that 40% of New Yorkers love the Biebs? Well, in this case, it's not likely, because what this confidence interval tells us is that we're 95% certain that if we were to survey 100 New York City residents again, that somewhere between 16% to 34% of them would tell us that they love the Biebs. So 40% is not a reasonable value because it doesn't fall within that interval. Now you might be asking us, what does this 95% mean? Well, that is how likely it is that this would occur again. Of course, I could survey people outside of the subway station and find out that only 15% of them loved the Biebs. So that's why we would say that we are 95% confident that the number falls within 16% to 34%. Let's see if you could try one of these problems on your own. In this problem, a survey was given to a random sample of 180 high school students to determine whether they support another season of the show, 13 Reasons Why. Of those surveyed, 81 students said they were in favor of another season. What is the margin of error for this survey? To answer this question, we'll use the margin of error formula. For the margin of error formula, you only need two pieces of information. You need to know the proportion of people in your sample, and you need to know the number of people in your sample. In this case, we surveyed 180 high school students, so that will be our n value. Then we need to find the proportion of people that said they would support another season of the show, 13 Reasons Why. Well, this is 81 people out of 180. That gives us 45%. Here we can plug in. First part is we simplify the numerator. Now divide the numerator by the denominator, and then multiply. That gives us our margin of error written as a decimal. In order to make it a percent, simply multiply by 100, and in this case, round to the nearest tenth, we get 7.4%. Let's try another example. This question here wants us to find a confidence interval, and you can see in each of these answer choices they give the lower value of the confidence interval and the higher value. What we first have to do is compute the margin of error. Remember that the margin of error formula only needs two pieces of information. We need to know the number of people in our survey, and we also need to know the proportion of them that answered it. Here, the n value is 50 participants, and of those, 34 said they would vote for candidate A. 34 divided by 50 is 68%, or 0.68. Now all we have to do is plug this information into our formula. Calculate the numerator. Divide by the denominator, and take 2 times the square root of the entire piece. We get this number, which is about a 13% margin of error. Multiply it by 100 to make it a percent, and rounded to the nearest percent would be 13.2%. Once we have the margin of error, we can create a confidence interval by taking p hat and adding and subtracting the margin of error. Here we saw that p hat was 68% and our margin of error was 13.2%, so we would plug that in. 68% minus 13.2% would give us 54.8%, and if I take 68% and add 13.2%, I get 81.2%. Well, what does that mean? That means that if we were to conduct this survey again of 50 students, we would be 95% sure that the number of respondents that would vote for candidate A would be somewhere between 54.8% and 81.2%. So maybe we did this again and that response was 55% of students favor candidate A. Maybe we did this survey again and we found that 60% of students determined that they would prefer candidate A. We just know that that number is somewhere between here. You may be asking yourself, well, that's a really large range. That's not very accurate to know that it's between 54.8% and 81.2%. And the reason that that interval is so large was we didn't ask many students. We only asked 50 students. What you'll find is the larger your sample is, or the more people you ask, the confidence interval gets smaller because you have a more accurate response. Let's try another example. In this example here, what we want to do is use the information given to find which of the following values is not reasonable for the actual percentage of the population that would vote for a certain presidential candidate. What's nice about this problem is when we go to create a confidence interval, we already have a lot of the information. We don't have to calculate the margin of error by hand because they already gave it to us. They told us the margin of error was 3.5%. We also don't need to calculate the average or the proportion of the sample because they already gave it to us. It was 40%. Now we can plug those into our formula and find the confidence interval. Plugging in 40% and subtracting 3.5% and also adding 3.5% would give us this interval. This means that this is probably, for our population, where the percentage lies of the people that support this presidential candidate. Now all we have to do is look at these pieces and see which one is not reasonable. 37% is a very reasonable value as it falls within the confidence interval. The same is true of 38.1% and even 43%. However, based on our calculation, 45.1% is not a reasonable value. Let's try one more question. In this three-part question, we want to bring everything together. This question reads that in April of 2020, ABC News gave a survey to a random sample of 1,000 New York City residents to determine if they approve of Trump's handling of the coronavirus. Of those surveyed, 110 residents said they approve of Trump's handling of the coronavirus so far. Part A. Find the margin of error to the nearest tenth of a percent for this random sample of New York City residents. Part B. Create a confidence interval for the actual percentage of New York City residents that approve of Trump's handling of the coronavirus. And Part C, is 10% a reasonable value for the actual percentage of New York City residents that approve of Trump's handling of the coronavirus? Explain. In order to find the margin of error, we need two pieces of information. We need to know the proportion of New York City residents that approve of Trump's handling of the coronavirus, and we need to know how many were sampled. Well, 1,000 people were sampled, and of those, 110 residents said they approve of this job. Finding that proportion would be 11% or 0.11. To find the margin of error, simply plug this information into the formula. Simplify the numerator. Divide by the denominator, and now compute the margin of error by doing 2 times the square root of that number, knowing that your calculator may display that number in scientific notation. Doing so gives us about 1.9%. Of course, we want to actually make this a percent by multiplying by 100. Rounding this to the nearest tenth of a percent, we get 2%. Answering part A, the margin of error for this study is about 2%. Part B says, create a confidence interval for the actual percentage of New York City residents that approve of Trump's handling. Well, we know the formula for the confidence interval takes p hat and adds and subtracts the margin of error. So taking p hat, which was 11%, and subtracting 2% gives us a lower value of 9%, and adding 2% gives us a larger value of 13%. So we're pretty sure that somewhere between 9% and 13% of New York City residents approve of Trump's handling of the coronavirus. Part C is going to ask us to check for a reasonable value. We want to know, is it possible that 10% of New York City residents approve of Trump's handling of the coronavirus? The answer is yes. 10% is a reasonable value because it falls within the confidence interval from 9% up to 13%. I hope in this video you learned how to calculate margin of error and how to use margin of error to create confidence intervals. Further, I hope you also learned that once we get a confidence interval, how can we tell if something is a reasonable or unreasonable value? Until next time.